Okay, let's jump into page 2. Question number 4. Draw math with the points 2, negative 3, negative 4, 3, 0, 5, and 3, 2. So let's go ahead and do what every student likes to do, and that is just draw our x and y axes right down the middle of the paper. I know I encourage you not to do that, but to look at the points first and kind of make an educated decision about where the x and y axis should go, but I'll tell you that in this case we're going to be okay doing it like that. So let's go ahead and plot these points. I got m at 2, negative 3. I got a at negative 4, 3. We got t at 0, 5. And then we got the last one there, h at 3, 2. Okay, so we're going to go ahead and draw in that quadrilateral. Looks like this. And the next thing is kind of tedious, and students really struggle with this. In order to determine exactly what type of polygon this is, we need to use side lengths and slopes to justify our conclusion. I'll tell you, I think it's a trapezoid. I mean, it looks like a trapezoid, but I can't guarantee that until I actually calculate some slopes and some lengths. So let's go ahead and let's do all the slopes first. All right, we've got our slopes calculated there, and the only thing that jumps out at me is I've got two slopes there that are equal. That tells me that those sides are parallel. So I know that segment MA has to be parallel to segment TH. Now let's go ahead and calculate some side lengths. Since I'm just going to be comparing numbers here, I don't actually have to approximate that square root as a decimal. I'm going to go ahead and leave these all as square roots. All right, folks, there you have it. And what I notice here is that we have no sides congruent because none of these values are equal. Okay, so now it's time to make a conclusion about what we think this shape actually is. All we have is one pair of opposite sides that are parallel. I can go ahead and add the parallel marks now because I justified that by comparing slopes. So now we're ready to make our conclusion. If you check your org chart, you'll find out that the only quadrilateral that has one pair of opposite sides which are parallel is the trapezoid. So quadrilateral math is a trapezoid. Okay, we got one problem left to do here. It's number 5. Given the figure shown right, determine the values x and y and describe how you determined each value. Okay, so the first thing I notice is that I've got congruent marks here and here. That means that point B is a midpoint of segment AC. I also have congruent marks here and here. Same thing is true of D. D is a midpoint of segment CE. Since B and D are midpoints of the sides of a triangle, that makes segment BD a midsegment. Properties of a midsegment. Midsegments are parallel to the opposite side and half of AE's length. Those are properties of this new vocabulary term in this chapter, midsegment. Okay, let's continue on. Next conclusion I want to make is this. Based on parallelism, the measure of angle E has to be equal to the measure of angle BDC. So I'm just going to highlight those for you here. The measure of angle E down here, this one, has to be equal to the measure of angle BDC because of the fact that we have parallel lines. Let me go ahead and mark the parallelism on the figure. Parallel. That means those are both 49 degrees. And the reason why, that's alternate interior angles at work. Okay, next thing I'd like to use is the triangle angle sum. That means what I have in this big triangle, I have x plus 49 plus 70 has to be equal to 180 degrees. That gives me a value of x at 61 degrees. Last but not least, let's talk about y. Since we know that segment BD is half of segment AE length, we can write this equation. Y equals 1/2 of 18. That tells us that y equals 9. All right, that's it for question 5, except for a little bonus here. What is the name of the segment labeled y in the triangle above? Folks, we've already answered this. It's a midsegment. All right, folks, that's it for the practice test. Good luck on the real thing.